Welcome back. So next I want to talk about the experiments that we did with Floatroid and the kinds of results that we obtained. So back then, in 2014, what was actually interesting, like I said, was we had obtained feedback from certain reviewers who said, well, but there are already other Android analysis tools out there, and they also do taint analysis. So what's better regarding your own tool? What can Floatroid do better than these other tools? Why do we need another Android taint analysis tool at all? And well, the reviewers were right in the sense that no established benchmark actually existed to show how bad these existing tools actually were, that they were not working at all, in fact, and that Floatroid would be doing much better. And because no such benchmark actually existed, we actually created one on our own. So I think that's something you should always do only as a last resort. Of course, it's nicer to be able to use benchmarks that have been created by other people, because that can definitely reduce bias. But in this situation, there was no other way. Nobody else had done this. So we actually published ourselves a benchmark called Droidbench as part of this PLEI publication. And Droidbench actually back then comprised 64 different test apps. So this is really a micro benchmark that is not containing real-world runnable, representative apps. That's not the idea. Instead, we wanted to test individual features of static analysis that are important in the wild and that the static analysis need to cover. And so we had certain apps that were testing for complex data structures or callbacks, lifecycle, then field and object sensitivity, also app communication, but also intercomponent communication within single apps. Reflection, also implicit control, implicit flows. These are basically information leakages through control flow branches, so you don't necessarily leak the data itself, but you leak information about data. And sometimes, depending on the configuration, using Floatroid, you can also detect this. But there were also other tools who did not support this. And so back then we had 64 different test apps. By now we have version Droidbench 3.0, and it has been extended with quite a number of additional apps since. That's actually something very nice about this project. So since day one, Droidbench has been available as open source. It has been used by many, many other papers really as a benchmark to test the quality also of tools that were published later. I think that's one of the reasons for why actually the Floatroid paper has been so successful. And over the years, we and others have contributed further test apps so that we have also significantly raised the bar for Floatroid itself, but also for other tools over the years. Back then, there were a number of other static analysis tools that already existed, and I've listed pretty much all of the ones that were available back then on the slide, and we've also listed them in the paper. The problem was really that we wanted to compare all of these tools against Floatroid at the time, but basically whenever we emailed any of the authors to please make their tool available to us, they all had one or the other excuse. I think there were a couple who at least made an effort to make the tool work for us, but actually even the authors themselves, they couldn't anymore. So that tells you something about reproducibility. And many other authors didn't even respond or just told us they wouldn't give us the tool for comparison. So luckily, this has changed a lot over the last few years. So these days, a lot more scientific conferences are actually asking for these artifacts to be made available and for things to be reproducible. It's still not fully required, but they're pushing for this. But back then, it was just really bad. So we really couldn't actually do this comparison. But we could, of course, measure Floatroid itself. And we also actually measured then two commercial tools, at least, that obviously were available. So we measured IBM AppScan Source at the time and HP Fortify. And this was on Droidbench 1.0 back then. And these were the precision and recall numbers that we got. So you can see that compared to these two commercial tools, FlowDroid had definitely a higher recall, but even a much higher precision, right? So the precision was really 93%. So only 7% false positives on this benchmark. And recall was also pretty good. That still doesn't tell you anything, of course, about real-world apps, right? So for real-world apps, the numbers might look a bit different, but still it gives you some indication of the analysis quality overall. So I think the relative comparison is valid, but the absolute numbers, they might actually change on real-world applications. And yeah, so that actually concludes my presentation on FlowDroid. So what was important that we have with FlowDroid attained analysis from sources to sinks, and actually presented to you how we were pushing for high recall and also high precision, so a low number of false positives. I talked about the Android lifecycle and how we model it, and also callbacks to actually maximize recall of FlowDroid. Then I also talked about the forward-taint analysis and backward alias analysis, and how that helps FlowDroid to really get decent precision. And we talked about, if I had to do this again, we would probably do it with Boomerang. But considering that this was in 2014, we had actually already a pretty good solution back then. Then I presented to you the Droidbench benchmark suite that we had published, and also the empirical results that we had obtained at the time. I should say that in the paper we published these results on Droidbench, but since then we have also applied FlowDroid in numerous other contexts. So we have applied it to real-world applications quite successfully. Actually, one of the largest app store operators worldwide is actually using FlowDroid also commercially to do some vetting in its app store. So it can definitely scale, and it can definitely be some good indicator also of malware and vulnerabilities. Although for this purpose, it's these days also often used in combination with other approaches. So for instance, if you're looking into how Google or maybe also Huawei in its Chinese app store, how they are vetting Android apps, they're not just relying on static analysis on its own, but they're also relying on dynamic analysis. They're even having some automated UI testing tools that actually exercise the apps to some extent. And then they're also using some machine learning techniques to be able to react also to modifications in the malware, so that these can be more easily detected. So it's a big machinery that people are using to try to keep their app stores clean. And static analysis doesn't cover all of it, but it's certainly one important component. Yeah, and that concludes my presentation for today. I'm looking forward to seeing you again next week. Bye-bye.